Imagine the sun going out, not at night, in the middle of the day. Picture a sky that turns the color of soot and stays that way for a year, maybe longer, while ash falls like gray snow and the temperature drops until the growing season simply stops. This is not a movie. It is a memory, strangely, encoded in your own DNA. Because somewhere around 74,000 years ago, a volcano in what is now Indonesia did something no mountain on Earth has done since. And some scientists think it almost ended our species. This is the story of Toba. Part 1. What actually happened? Let's start with the mountain, or rather what used to be a mountain. In the north of the island of Sumatra sits a lake today called Toba, a vast sheet of water about 100 kilometers long and 30 kilometers wide. But that lake is the scar of a wound. Beneath it lies the remnant of a magma chamber that, around 74,000 years ago, tore itself open. Geologists call what happened a supereruption, the highest rung on the volcanic scale, a magnitude 8 event. To picture the size, when Mount St. Helens exploded in 1980, it threw out about 1 cubic kilometer of material. Toba threw out more than 2,000. It was, quite possibly, the largest explosive eruption anywhere on the planet in the last 2.5 million years. Here is how an eruption like that works. Deep underground, magma is not a tidy lake. It is a slush of molten rock and dissolved gas under enormous pressure. In most volcanoes, the gas escapes little by little, and the mountain vents and grumbles for centuries. But in a supervolcano, the magma is thick and the gas gets trapped, building pressure until the rock above simply cannot hold. When it lets go, the result is not a neat cone of lava. It is a blast that punches a column of ash and gas tens of kilometers into the sky, high enough to punch through the weather and reach the stratosphere, where the high winds carry it around the entire world. And when the magma finally drains away, the empty chamber can no longer hold up the ground above it, so the land collapses inward, forming a vast sunken crater geology SDS called a caldera. Toba's caldera then flooded and became the lake we see today. Part 2. The year without a summer. So what did that mean for the planet? First, the local devastation. The blast itself would have flattened forests for hundreds of kilometers and buried the landscape in meters of glowing ash. But the global effect is what matters for our story. The ash, and more importantly a gas called sulfur dioxide, rose into the upper atmosphere and spread into a haze that wrapped the Earth. Sunlight bounced back into space, and the world got cold. How cold? This is where scientists disagree, and we will come back to that. But the rougher estimates suggest the average temperature over large parts of the globe may have dropped by several degrees Celsius, perhaps as much as 6 degrees or more in some regions, and stayed depressed for years, possibly a decade. Crops and wild plants would have failed. Rivers and lakes may have frozen in places they normally never do. And the ash itself, falling across South Asia, left a layer you can still dig down and find today, a band of gray dust that marks the moment the sky went dark. Traces of that eruption have turned up astonishingly far from Sumatra. In the soils of India, in ocean cores from the South China Sea and the Arabian Sea, even in tiny amounts, locked in the ice of Greenland. One volcano in a few days wrote its signature across half the planet. Part 3. Did it almost end us? Now to the question that gives this story its weight. Did Toba push the human species to the edge of extinction? The idea was proposed in 1998 by a researcher named Stanley Ambrose. He noticed something odd in our genes. Every person alive today is remarkably similar to every other, far more similar than, say, 2 chimpanzees from the same forest. One explanation for that tight similarity is that our ancestors once passed through a very narrow gate, a bottleneck where the population crashed so low that whole branches of humanity simply vanished, leaving only a small founding group behind. Some estimates put the number of breeding humans after such a crash as low as a few thousand, maybe even around 1,000 to 10,000 individuals worldwide. Ambrose's bold claim was that Toba caused it. He argued the eruption triggered a volcanic winter, followed by 1,000 years of cooler, harsher climate, and that this squeezed the human population down to that tiny remnant, a few thousand. Out of all the humans who had spread across Africa and beyond, only a handful left descendants. If that is true, then you and I are the children of survivors of a near miss. It is a beautiful, terrifying idea, and it is also contested. Part 4. What the evidence really says. The problem is that a bottleneck in our DNA does not come with a date stamped on it, and the ash does not come with a death toll. So researchers went looking for humans who were actually there, and they found them. In southern India, at a site called Jwalapuram, archaeologists discovered stone tools both below the Toba ash layer and above it, made in the same tradition, suggesting people lived there before the eruption and kept living there after it. Pollen records from parts of Africa show ecosystems disturbed by the cooling, but recovering within years to a few decades, not collapsing for a millennium. And many geneticists now think any human population crunch happened earlier than Toba, or was milder than the original dramatic estimate, and may have had nothing to do with the volcano at all. So where does that leave the bottleneck? Honestly, in a softer form, Toba was almost certainly a catastrophe for anyone nearby and a serious stressor for the whole species. But the clean story of a global near-extinction, a single volcanic event holding humanity by a thread, is probably too neat. The truth is messier, and in some ways more interesting. Our ancestors were already tough, already widespread, and they weathered a disaster that would have erased almost any other large animal. Which raises a darker thought. What if the eruption had been just a little bigger, or the cooling a little longer, or our ancestors a little fewer? That is the version of the story where there is no one left to tell it. We will never know how close that version came. Part 5. Could it happen again? Which raises the obvious, nervous question. Could the Earth do this to us again? The answer is yes, eventually, and no, probably not soon. Toba is one of only a handful of known supervolcanoes on the planet. The others include Yellowstone in the United States, which has erupted catastrophically in the distant past. Toba in New Zealand. Campi Flegrei near Naples in Italy, which today sits half under a city of 1 million people. These are not cone-shaped mountains. They are vast calderas, the collapsed craters of eruptions that already happened, hiding magma systems that could, one distant day, stir again. But here is the scale of the odds. A supereruption somewhere on Earth happens only about once every 10,000 to 100,000 years. The chance in any single year is small, perhaps around 1 in 10,000 or less. You are far more likely to be struck by almost anything else. And if one did happen, the world we live in is not the world of 74,000 years ago. We would see it coming. We monitor these calderas with networks of sensors that track even the smallest ground swell, the faintest change in gas, the slightest tilt of the land. We could model the ash, stockpile food, and coordinate across borders in a way our ancestors, huddled in a cooling world with only stone and fire, never could. So the real lesson of Toba is not that we are due for apocalypse. It is that our species has already survived its closest brush with the void, and we did it with nothing but stone tools, fire, and each other. Part 6. Where that leaves us. Today, Lake Toba is calm. Tourists paddle across water that covers the mouth of the volcano that almost ended us. The magma is still down there, slow and sleeping, but for now, the scar is just a beautiful lake. And if you ever visit, stand at its shore and remember, the reason you exist to stand there at all may be that a small band of humans, somewhere in a colder, darker world, refused to disappear. We will never know their names. But they are why there is a we at all. The volcano did not finish the story. It just made the next chapter possible.